You know, hydraulic elevators, they seem so simple, right? A big, powerful jack just pushes a cabin straight up. But it turns out there's this really fascinating engineering puzzle hiding in plain sight, one that makes the difference between a smooth ride and a total disaster. Let's get into it.
I mean, really think about it for a second. To get elevators to go up higher and higher, those jacks have to get taller and, well, skinnier, and that makes them really vulnerable. So what's stopping them from just bending or buckling? What's the hidden force that's keeping everything safe and straight? That's the big question we're going to answer today.
All right, so here's how we're going to break it down. First, we'll look at the hidden danger lurking in these tall jacks. Then we're going to reveal the simple but kind of brilliant solution. After that, we'll dive into the physics of how it works, check out the engineering that keeps it all safe, and finally, see how experts like Navin Puya lift all of this into practice.
Okay, so our story really starts with a very specific kind of jack, the telescopic jack. This is the piece of hardware that lets elevators travel long distances without needing a crazy deep pit dug underneath.
Yeah, they work just like an old-school pirate's telescope, you know? Extending out in different stages to lift the cabin higher and higher. It's a really clever design for saving space. But that long, slender profile, that's its Achilles heel. It makes it super susceptible to these powerful forces that are just trying to bend it and buckle it.
And that brings us to the main villain of our story, the bending force. You see, even a tiny bit of this force on a tall, thin piston can start to deform it. And in the worst-case scenario, it can cause it to buckle. And buckling isn't a slow bend. It's a sudden, catastrophic, total structural failure. So how on earth do you defeat a force like that?
Well, funny enough, the solution isn't some super complex, high-tech gizmo. Nope, it's actually a pretty humble but absolutely brilliant piece of mechanical engineering.
And here it is. This is the hero of our story, the jack guide shoe. These little things attach right onto the jack, and they slide along the elevator's guide rails. They might not look like much, but their job is absolutely critical. They absorb any sideways force and transfer it away from that vulnerable jack and into the super sturdy guide rail system.
And when they do that, they pull off a little bit of engineering magic. They completely change the physics of how the jack behaves when it's under pressure.
This slide is everything. This is where the whole transformation happens. See, without guide shoes, the jack is basically what engineers call a free column. It's standing all on its own, and any little push from the side can easily bend it. But when you add the guide shoes, it becomes a multi-supported beam. Now it's being held steady and supported at multiple points all the way up.
And here's a perfect way to picture it. Trying to push down on the top of a drinking straw? Yeah, it's going to bend and collapse almost instantly. That is a free column. But now think about trying to bend a shelf that's screwed into the wall with a bunch of strong brackets. Good luck. It's incredibly strong because those forces are spread out. That's our multi-supported beam.
So you might be wondering, where do these bending forces even come from? Well, the main culprit has this fancy name, eccentric loading. But it's actually a really simple idea. No elevator car is ever perfectly balanced. You've got people moving around, luggage being loaded unevenly. All that stuff means the center of gravity is constantly shifting just a little bit off-center from the jack. And that tiny misalignment creates a surprisingly powerful bending force that the guide shoes have to fight.
Of course, none of this is left to chance. Making sure this system is 100% safe takes some very precise calculations to make sure every single part can handle the stress it's going to be under.
Engineers follow this really strict process. First, they figure out the absolute worst-case scenario for an off-center load. Then, based on that, they calculate the exact sideways forces those guide shoes are going to have to deal with. From there, they find the precise spot on the jack where the bending stress will be the absolute highest. And finally, they double and triple check that the jack's material and its design are way more than strong enough to take it.
And here's the payoff for all that hard work. The amount of force it would take to actually make the jack buckle becomes astronomically high, so much higher than anything it would ever face in the real world. Basically, buckling is completely engineered out of the equation. It becomes a non-issue.
And this is exactly where a company that specializes in this, like Navin Puya Lift, really shows their expertise. It's not just about slapping on some guide shoes and calling it a day, it's about implementing them perfectly.
It's really a whole system approach. They strategically place the guide shoes in just the right spot to best fight those bending forces. They use super robust materials that aren't going to wear out. They insist on absolute precision when they install everything, so there's no stress built into the system from day one. And they really push for diligent maintenance, because that's what guarantees it all works perfectly for years and years.
As Nova and Puya Lift themselves put it, it's their deep technical knowledge that ensures these systems are built for maximum safety, stability, and a long life. So, the next time you step into a hydraulic elevator, just take a second to appreciate that simple, brilliant bit of engineering that turns a fragile straw into an unshakable beam, and maybe wonder what other invisible forces are keeping you safe every single day.